Hello everybody, I come back yet with another segment. We are still doing Euclidean geometry and we're doing question 8 in one of our previous question papers. This is technical mathematics, suitable for grade 11 and grade 12. You can answer this question. Alright, what do we have? They say that the diagram below, O is the center of the circle, Tn is a tangent to the circle, and angle A4 it is equal to 46, and then CD it is parallel to Tn, where C1 it is equals to 20 degrees. The first question is, what is BCA? Let's highlight and see where do we find BCA. So if you follow this train from B to C and then you go back down there to A, you will notice that the angle they're talking about is this one here, C2 and C3. That is our BCA. Now if you go back to your theorems, you will recall that we have a theorem that says the angle between the tangent and the chord. So if you look at the line BA, this is your chord, and then if you look at this this line here TN, it is given on the statement that TN is a tangent to the circle. So in other words, the angle that is created between the tangent and the chord, this 46 degrees, it is equal to the opposite interior angle up there. In other words, BCA referring to C2 and C3 combined, they give us 46 degrees. That is the angle between the tangent and the chord. So BCA, it is equal to 46 degrees. That is the angle between the tangents. We call this tan-chord theorem. The angle between the tangent and the chord. So tan-chord theorem. 8.1.2, the angle A3. Let's clean up our diagram here so that we can create a clear picture of where we see A3. All right. So where do we find A3? A3, it is this angle inside our diagram. So the question wants us to determine that angle. So if you observe into your diagram, you will notice that you have a line from the center, and that line from the center, it goes straight down to the circumference of the circle. Now when this line reaches the circumference of the circle, you will see that you still have that Tn. You see that line Tn there, and what do you notice? You will see that OA, the line OA, it is perpendicular to that line NT. So that means that at this point of contact here, the angle, it is 90 degrees because the radius is perpendicular to the tangent line. The radius there, it is perpendicular to the tangent line, which means that from O to A to T, the angle there in total, it is equal to 90 degrees. So we can simply say that OAT, it is equal to 90 degrees. Why did we say that? That is a tangent, our tangent, and that tangent is perpendicular to what? To the radius. So that means angle A3, it is equal to 90 degrees minus what? This one that is given as 46. We're going to subtract 46 from 90 degrees, and then we're going to find angle A3 to be how much? If you press it on your calculator, you will get 44 degrees. So that makes angle A3 to be 44 degrees, and you can write that as, that is your tangent perpendicular to what? To the radius. That is our angle there, A3. Now the next one that they want us to find, it is A1. Let's clear up the situation here and find the angle A1. All right. Before we answer A1, let's establish our information. This one here, we have already established that this one, it is 46 degrees. And this one here, we've already established it as 44 degrees. Angle A1 is this one. They want us to find this one here. Remember, you have parallel lines. They told you that CD, it is parallel to TN. So this line here and this one here, both of them are parallel. So how do they help us to answer this question? You have this line in between parallel lines. Do you see what it creates? It creates a Z shape. So this Z shape here, do you see this Z shape? What does it mean? It means that angle A1, it is alternating with the other angle up there. The total angle here, it is alternating with this one. So it means that DCA, it is equals to 20 degrees plus 44 degrees. Okay, so this is 8.1.3. So it means that DCA, it is equals to 20 degrees, that angle there, 20 degrees plus 46 degrees. The total of this, it gives us 66 degrees, right? So once you have the total angle there of 60 degrees, this 60 degrees angle, it is alternating with A1. It is alternating with A1, which means that A1, it is equal to 66. It is equal to 66 degrees. And how do we establish that? We've got alternating angles there. We've got alternating angles. So A1, it is equal to 66 because it is alternating with DCA. From A, if you go to N, you create a Z shape. So that Z shape, it means that two angles are alternating. This applies when you have two parallel lines, which they have already told us here that our lines are parallel. So angle A1 here, we can confidently say that it is 66 degrees. We have what? Alternating angles. Our angles are alternating. All right, now O1. Determining O1 is very much interesting. There are multiple ways you can determine the angle O1. So O1, it is this angle here. That is O1. So how do we find that? Look at this one. We're gonna go back and let me clear up this, and then also here I'm gonna clear up this. I want you to say this very, very, very nicely. So okay, what do we have? Let's draw our from C. From C you got B, and then if you go down there you've got A. And then if you observe very carefully, you will notice that you have a chord here. And then after having that chord, you have an angle between the tangent and the chord. Remember, you were told that NT is a tangent to the circle. Already you have established that this angle here, it is 66 degrees. So the angle between the tangent and the chord, the one that you found here, it is 66 degrees. Now this angle, it is equal to this guy here at B, 66 degrees. Tan chord theorem, the angle between the tangent and the chord, it is equal to the opposite but interior angle. So here is our chord. So the angle between the tangent and the chord is equal to the opposite interior angle. Now, if you have this angle at B, which is 66 degrees, look at this, look at this. If you draw this part here, what do you see? You will see that the angle at the center is 2 times the angle at the circumference theorem. So that means the angle here at B is at the circumference, which means that angle O1, they told us O is the center. So that means angle O1 will be 2 times the angle at the circumference. So if you do your multiplication, you will notice that 66 multiplied by 2 is going to give us 132 degrees. Nah? Nice one. So let us tidy it up and answer it correctly here. 8.1.4. What do we say? We say that we start here by saying that angle A1, it is equal to that angle there, B, that is equal to 66 degrees. Why do we say that? That is the angle between the tangent and the chord. So we say that we have a tan chord theorem. From having that, then we can say that angle B, it is equals to 2 times, not angle B, angle O1, angle O1, angle O1, it is equal to 2 times angle B. Why do we say that? That is the angle at the center. That is the angle at the center. It is equal to 2 times the angle where at the circumference. So that means angle O1, it is equals to 2 times 66 degrees, which gave us 132 degrees. And that is how you answer this question, boys and girls. Let's catch and see each other in the next segment. Before I close that, this is 132 degrees. Thank you very much. See you in the next segment. Bye-bye.